Here is a simple logic question for you. Jack is looking at Anne, but Anne is looking at George. Jack is married, but George is not. Is a married person looking at an unmarried person? Is it A, yes, B, no, or C, cannot be determined? While it might seem easy, more than 80% of people answer this question incorrectly. If you concluded that the answer cannot be determined, or that no married person is looking at an unmarried person, then you are one of them. The correct answer is in fact, yes, a married person is indeed looking at an unmarried person. The answer becomes clear when we sketch it down. Anne's marital status doesn't depend at all. If Anne is married, she, a married person, is looking at George, an unmarried person. On the other hand, if Anne is unmarried, Jack, a married person, is looking at her, an unmarried person. If I flip a coin 5 times in a row, and each time it lands on tails, the next toss surely should result in heads, right? Wrong. We tend to think that since there's a 50-50 chance of coins landing on each side, when we get a long streak of tails, heads is overdue. The next flip surely should be heads, we think to ourselves, but in reality, there is still a 50% chance for it to be either side. Consider these statements. All of P are M. All of S are M. Therefore, all of S is P. Is this a correct syllogism? When we rephrase the syllogism with real-life concepts, the fallacy created is painfully apparent. All like buttons are buttons. All subscribe buttons are buttons. Therefore, all like buttons are subscribe buttons. But we know that like buttons are not subscribe buttons, hence this syllogism is wrong. We tend to believe these wrong syllogisms all the time, but why is that? One of the most common logical errors that people make is called the belief bias. If a syllogism's conclusion is something you believe to be true, then you are more likely to judge the conclusion to be that way. The same effect is observed when you believe an argument to be false. This is one of the main reasons why some people to date still refuse to believe obvious facts such as the existence of COVID-19, climate change, or the fact that the Earth is round. Here's another logic problem for you. 4 cards are sitting on a table. Each card is a number on one side and a letter on the other. 2 of the cards are number side up and 2 are letter side up. You need to find out if the following rule is valid. If a card is a vowel on its letter side, it has an even number on its number side. Which cards must you be turned over to find out whether the rule holds? If you chose to turn over the 2 card, you focus on confirming the rule rather than falsifying it. But the rule says nothing about whether an even number must have a vowel on the back, so turning the 2 card is of no help in verifying it. The right cards to turn are A and 5. What if we rephrase the same problem as such? Instead of numbers and letters, cards of a person's age on one side and what the person is drinking on the other. You need to check to verify that everyone drinking alcohol is at least 18 years old. It becomes clearer which cards we need to check, beer and 14 years old. Both of these problems have the same logical structure, with the only difference being the question's content. And how is it that solving the second task is easier? Well, we do not know for sure, but these results help the researchers understand that how well we think about problems highly depend on what we're thinking about. If you didn't get all the answers right in this video, don't worry. It's easy to fall into logical errors. People engage in higher quality thinking when the circumstances are right. So when you make a mistake, maybe it just means that you aren't giving it the right triggers.